And I'm going to pass it to Nick to go ahead and introduce our speaker for today. So Nick, take us away.
Yes, thank you, Michelle. Very excited to have Tony today with us. Tony is the author of 4 books, but I think he's also credited for 5 books. So we have today here, he's going to present or talk about his latest book, Your Wit is My Command, which, it doesn't, you don't always find a book in AI that it's funny, but this is, combines AI and fun. And there's also another one that was 2 or 3 years ago about Twitter bots, making machines that make meaning. Also a very interesting book. He also has written another book. It's called Metaphor, Computational Perspective. And there's another one even before that, exploring the creativity myth, linguistic creativity. And there's another book that by another Tony Veale, it's called The Orchard, which hasn't been written by our Tony Veale, but people actually ask him to sign it. I think he told us in private. So he gets credit for that as well. So Tony has a very long bio. He's a professor at University of UCL Dublin. So I'm reading that from his webpage. I'm not going to read all of it because it's too long. I don't want to get people bored. He has a lot of exciting things to talk about. He has been a researcher in the area of computational linguistics, cognitive science, cognitive linguistics, artificial intelligence since 1988 in industry and academia. He got his bachelor's from computer science from UC Cork in 1988. He has worked at the Hitachi Dublin laboratory. I see over here, it's very interesting. He has done work at the Psy Corporation in Austin. He built a web-based question answering system. I see here for a company called IntelliSig. And he was from 2002. He also participated in the DARPA-funded high-performance loadless spaces project, and another one related to that, rapid knowledge formation. He has been academic coordinator at UCD and lots of other distinctions and awards. So, Tony, the floor is yours. Thank you for speaking at Relational AI today.
Thanks, Nick. Thanks for a great introduction. And thanks, Michelle and Nick, for inviting me. It's my pleasure to be here today to talk about, I guess, was a somewhat quirky area of AI. I've always been drawn to the quirkier ends, the kind of the X-file ends of natural language processing and computational reasoning. The area I work in is computational creativity. So I'm going to go full screen on this. Yell if you can't see the slides. So I'm interested in general and in the context of this book with how we might give machines a sense of humor. And the 3 questions that we need to ask and answer is, what does that mean to give machines a sense of humor, to understand human humor and to perhaps generate humor of their own? Why would you do this? Because it makes them more socially aware, more communicable, easier to use, more curious, more creative. And then, of course, the big question is how? How can you do all of these things? Because humor is one of these cognitive capabilities that we have as humans that touches on almost every aspect of our intelligence. It's a branch of common sense, and it requires a tremendous understanding of the world and its nooks and crannies. I'm starting with a joke here, which was voted the best joke of the 2012 Edinburgh Fringe Festival. The joke goes, "I was raised as an only child, which really pissed off my sister." Now, I've split it up on this slide into a two-handed joke because jokes have this antagonistic conflict at their heart, and that really lends jokes to the double act structure is so common in comedy. And if we were to analyze the joke in terms of a knowledge graph, you'd identify all of the knowledge that one would need to get that joke. You need to understand what it is to be a child, what it is to be a parent, what it is to be part of a family, what it is to be an only child with doting parents, or what it is to be a favorite child in a family with multiple siblings, some of which are going to be jealous. And this is all world knowledge that one would expect an average person to have. And this is all essential to the joke, but the joke really pivots on a very quirky and unassuming piece of knowledge, the meaning of the word as. Bill Clinton famously argued over the meaning of the word is, and this joke pivots on the meaning of the word as. As can mean like, and as can mean is. So for instance, he returned as the president. That's as equals is. He speaks as if he knows what he is doing. That's as equals like. And we can partition the knowledge graph into two sections based on whether we take as to mean like or as to mean is. And those sections generally get called scripts in humor theory. And Victor Raskin, who kickstarted the computational treatment of humor back in the 80s, proposed his two-script semantic script theory of humor, which has been very influential in the field, and which fundamentally relies on the availability of knowledge graphs that have varying levels of knowledge. And of course, that's the real bottleneck in computational modeling of humor, getting the knowledge into the system and getting the system to understand where the pivots in that knowledge exist. Now, there's a possibility, and I think a default expectation with artificial general intelligence, that if you have a large enough AI that's general enough, that covers many aspects of the human experience, that a sense of humor will naturally develop, because a system like that would have to deal with the very many contradictions and incongruities and oddities that the real world presents to us all of the time. And this view of an emergent sense of humor from a complex AI, I think, is famously and perhaps best presented in the novel The Moon is a Harsh Mistress by Robert Heinlein. He imagines a supercomputer called Mike that runs a lunar colony, and Mike does everything for this colony, from managing the oxygen supply to issuing paychecks on a monthly basis. And one month, Mike issues a paycheck to a janitor in the amount of 100 million billion lunar dollars. It's a joke. There isn't enough money on Earth or the moon to pay that amount of salary. So what's Mike done? Well, Mike has issued a check that's worthless, but on the face of it, it looks incredibly valuable. Mike has explored the space of finance and recognized that the larger the number on a check, the more valuable the check. So the numbers go up and the value of the check goes up. And then there's a point at which the number on the check is so high that the check has no value. So you have this crashing fall in value. So Mike has issued a check with no value to a person who's going to see this and go, oh my God, I'm rich. Probably resign on the spot and run down the street screaming. So the joke is built on this discontinuity that the machine has discovered in its space of exploration. It creates an incongruity. The janitor is going, this isn't my regular paycheck. There's resolution. The janitor realizes he's the butt of a joke. The butt of a joke relies on a power imbalance. Mike is expressing his superiority over the people that he manages. He's thwarting expectations, but doing so in a way that is a so-called benign violation. So all of these buzzwords, incongruity, resolution, superiority, expectation, benign violation, they're all fragments of different theories of humor. And there are many theories to choose from, and none are very satisfying. And most really good jokes have elements of multiple theories in them. So we can only get so far by following the scholastic theories of humor. But what's important to note is that most jokes, I don't want to say all because it's a very broad phenomenon, but most jokes have this temporal discontinuity in them, where you have a gradual buildup of some quality. It reaches a crescendo, and then there's a sharp and sudden collapse. So the increase in the value of the check until the check is worthless. There's the increase in the mood of the janitor as he opens his paycheck, and his mood goes from what to, oh my God, oh, wow, I'm rich, yay. And then the sudden realization, no, it's a joke, and the crashing of mood. So you see this temporal course, this temporal signature everywhere in jokes. And of course, for the computer to recognize the effect on the emotions of the recipient of the joke, the computer needs what's called a theory of mind. It's not simply good enough to know how words connect with each other, or even how concepts connect with each other in a knowledge graph. It needs to know how the recipient's mind works and how their emotions are affected by those structures. And the joke is essentially hacking those structures to create this temporal discontinuity, this inflection of mood over time, which is very distinctive time course. This had led some mathematicians to propose theories of humor built around René Thom's catastrophe theoretic models of discontinuity in geometry. For instance, John Allen Palos proposed at a very general level a catastrophe theory model of humor back in the 80s, and I've explored that myself in earlier work. Basically, a joke is a manifold. It's a multi-dimensional space with this cusp-like structure, and if you follow the joke in its most natural course by leaping to conclusions, you follow course A, and that leads you to this sudden discontinuity and the feeling of, oh my God, what's happening? Whereas if you know your way through the joke, as the teller does, you'll follow route B. And of course, anyone who follows route A will eventually have to backtrack, accept that they've been wrong, and go down route B. Now, this is a lovely metaphor, but actually turning it into computational models is really difficult. It's very easy to say a joke is a manifold, but how do you actually interpret that in an algorithmic and data science way? I should say that comedians have a similar view of jokes. Here's a really old joke, which is analyzed by Greg Dean in his Guide to Stand-up Comedy. My grandpa died peacefully in his sleep. Now, if I tell you that, the cliche is that you imagine that grandpa died peacefully in his sleep in bed. In fact, in his own bed. We assume it's his own bed. If it was someone else's bed, that might be a different build-up for a joke, but here it's his own bed. But if you then say, grandpa died peacefully in his sleep, unlike his passengers who died screaming, then you have to reevaluate that assumption. Grandpa didn't die in bed. Grandpa died behind the wheel of a vehicle. Perhaps it was a school bus. Perhaps it was a bus full of old age pensioners, whatever. Anyway, these people he dies peacefully with a heart attack behind the wheel while they're screaming as the bus careens off a cliff. The mind fills in all of the gaps. That's the beauty of jokes. They make the listeners collude in the creation of humor. And even if you say that was in really bad taste, most of the bad taste has happened in the audience's mind. They can't really separate themselves from that. So if you take the mathematical view put forward by Palos, which is the catastrophe theoretic view, we see that it's simply a multi-dimensional version of the two-dimensional branching structure that comedians favor when they understand jokes. You've got the joke setup, the expected conclusion that follows from the stereotypes in the joke setup, but the joke includes a subtle and implicit gentle detour that leads to a surprising conclusion. If you've heard the joke before, or if you're the teller, that's the route that you go. If you haven't heard the joke before, you jump to conclusions, realize you're wrong, have to make a massive correction. And part of that correction involves recognizing you're wrong, updating your knowledge structures, and perhaps getting some pleasure signal from that act. So people have proposed that humor is a way of rewarding us for updating our knowledge and for debugging our common sense. And there's some sense to that, though I don't know if it's a complete model. But we do need to explain, as well as computationally model jokes, why do we tell them in the first place, and what is the value of them to us as a cognitive activity? Now, a view put forward by Jürgen Schmidhuber, one of the inventors of the long short-term memory network, is that expectedness can be quantified through compressibility. If you're familiar with stimuli, then it's easy to label them and to reductively reduce them to labels. And the more you can compress a stimulus, the more familiarity you can extract from it. So if you work in an M&M factory and you see M&Ms coming by on an assembly line, then you have tremendous compressibility. And if you suddenly see a tennis shoe on the assembly line, then that's going to take some explaining. And jokes present us with a buildup that allows us to expect a highly compressible phenomenon, and then we get something that is jarring, that's difficult to categorize, difficult to compress. And the degree to which we can compress it is a measure of how surprising it is. So compressibility as expectedness, lack of compressibility as surprise. Schmidhuber really leverages this to come up with theories of fun and art and beauty and joy. And there's more going on in all of those things than compressibility, but it's a really good foothold computationally to start talking about these things. So we can talk about the surprise we get when we hear, not like his passengers who died screaming, for instance, or which really annoyed my sister, right? Those punchlines which really don't fit with what has gone before. How do we quantify the surprise in those things? And we see surprise everywhere in our environment. And surprise is conceptual, it's based on conceptual expectations, but we can model it statistically. Wandering around the city here during lockdown, I always notice signs and I take note of them. Outside a church, I saw this sign, "Love can solve most problems." I found that quite surprising. I thought, here's a priest who's lost some of his faith. Surely it should say, "Love can solve all problems." So the most really struck me as odd. It's a bit like saying God forgives most sins. It's a kind of a meatloaf quality to it. So it's not a joke as such, but it's the kind of thing that you notice. It's out of kilter with reality, or we're out of kilter with expectation. Here's another sign I saw during lockdown. This Vietnamese restaurant started doing takeaway alcohol, and it said on its chalkboard, "Full list of takeaway beers and wives." Now you know they're not selling wives. Very strong expectation that they're not selling wives in this restaurant. And on closer inspection, it's easy to see that they didn't press hard enough on the chalk when they were writing the N, the downstroke there, and they meant to say beers and wines. Now, you don't need to be told that. We have a statistical expectation that beer and wines is much more likely than beer and wives. And we can fill in the mistake or correct the mistake for ourselves. So we can use statistics to recognize an incongruity, an anomaly, and we can use some kind of conceptual modeling to fill in the interpretation. So here we can use statistics to suggest the correction, but then we need conceptual modeling to say, yes, that fits, because someone that sells beer is likely to sell wine because they belong to the similar category. So interpretation reveals intent. It's one thing to recognize anomalies, it's another to interpret them. And I think this is where statistical and perhaps neural approaches go hand in hand with conceptual knowledge graph approaches to AI generally and to humor and creative phenomena specifically. So let's take a closer look at the data science approach to this. If I give you the build up to a joke, but it needn't be a joke, but it is. The dentist was grumpy because he had a bad day at the, what word would you fill in that last slot there? Well, statistics applied to the English language tell us that office is the most likely filler for that blank. Bad day at the office. This little table I'm showing here is an extract from the Google Web Ngrams. As you know, an n-gram is a contiguous sequence of n tokens in a data stream. And the Google Web n-grams are part of Google's index of the web. And the counts are raw counts from when Google generated these n-grams. The set I use was generated back in 2006. So in the Google Web Index, bad day at the office was found for 5,403 times. Whereas bad day at the beach, much rarer, 241, bad day at the tables, bad day at the track. Maybe the dentist is a gambler. He was upset because he had a bad day at the track. But it's much more likely he simply had a bad day at the office. Now, how would you turn that into a joke? Well, the joke needs to play on the fact that we're expecting office. So we give something different. But different is not necessarily funny. For instance, you could say, bad day at the dog. We've observed that in the data. That doesn't make any sense. It's statistically improbable, but possible. It's just not funny. If you were to say bad day at the orifice, which is the joke, the dentist was grumpy because he had a bad day at the orifice, then that somehow meets our expectations of office and defies our expectation of office, but can be explained as a substitution, orifice being a fancy way of saying mouth. A dentist spends all day with his or her hands in someone else's mouth, a somewhat unpleasant way to earn a living. And the orifice is in the office. Okay. So we explain that that's a pun, but more generally, it's what we call an optimal innovation. An innovation in the sense that you're presenting something new, and it's optimal because it's also strangely familiar. And it's a kind of a sweet spot in this saddle. It's a saddle point between familiarity and novelty.
Are you taking questions, Tony?
I can if you like.
Yeah, so when you said a somewhat unpleasant way to make a living, David Sanders cracked up, okay? Because it was sort of sarcastic and so on. Is that humorous pattern interpreted in the same way that you're describing here, or is that different?
Yeah, I think that's called litotes. That's ironic understatement. So you put a pleasant gloss on something, and again, that works at a different level. It's not a pun, but irony generally has been described as a kind of conceptual pun, where instead of replacing one word for another, you replace one feeling, one sentiment, and one expression for another. For instance, if I invite you to Dublin and I say June is the best month of the year in Dublin, the weather is glorious, we'll go out and see the countryside. Oh, the weather in Dublin in June. And then you come to June to Dublin, and it's raining, as it is. It's raining. And you look around and you go, the weather in June. You're being sarcastic.
Right.
But you're also punning at a high level because you're repeating what I said in a different context. You're echoing. So the joke is an echo, and it's a corrupt echo. Somehow you're echoing something at a formal level, but where the feelings are different, right? So you're presenting something negative as being more positive. You're presenting something positive as being more negative, but you're using an echo to create this parallax. Now, this is a point I'm going to raise later on, in that we need two models to understand humor, because you need to be able to take a dual perspective on the phenomenon or the stimulus that you're modeling. And if you're trapped in a single stimulus, or sorry, if you're trapped in a single model, for instance, a language model, you can't jump outside of yourself. So the brief answer is, yes, there's a continuum of phenomena here that we can model statistically and conceptually, from irony down to punning, and there is a family resemblance between all of them. But of course, the irony is much harder to do than irony and understatement. I've been trawling through Twitter data for a project that we've been doing. We've been looking at anti-vax debates on Twitter. And I came across this tweet that really cracked me up. It said, JFK would still be alive today if he had been vaccinated. And of course, you need to know all of the knowledge behind. JFK. And this was in response to the White House saying that they were delaying the release of certain papers about JFK because of the COVID emergency. And that the hashtag that was on this tweet was "Get Vaccinated." So I thought it was a pro-vaccine tweet, but I had to go looking, and it was deeply ironic. So anyway, the irony is really complicated, and you often don't know the stance of someone that creates this deniable, plausible deniability. But the mechanisms are similar. They're just more difficult. But we can do something with a language model. So if you're a language model, as you know, is a probability distribution over the strings of a language. We can assign different probabilities to different strings and use relative probability differences to figure out which is the best way of saying something or which is the most unlikely way of saying something. So we expect bad day at the office, we get orifice. Orifice has a 0 probability of turning up, or has a minuscule probability of showing up. But it has this phonetic similarity to office that substitutes for the probability. And we get this balance of low probability but high similarity, which in itself doesn't make it funny. There's something a little transgressive about the word orifice. And there's something, I suppose, unpleasant about the idea of imagining someone working in an orifice. There's a lot of work in this simple joke. And this is another thing about jokes. There's very few simple jokes where there's only one thing going on. Anyway, the point here is that optimal innovations balance expectation with novelty. And that ranges from puns to irony. And to give you another example, perhaps a much more practical example, last year in Dublin, between the first and the second lockdowns, myself and my wife, we went to the cinema. They briefly reopened, and we went to see Tenet. We're big Christopher Nolan fans, and this was a sci-fi film. I don't know if you've seen it, but it's very complicated, a bit of a brain bender, a head wrecker. It's about people traveling through time, not in the normal direction. They're traveling backwards through time using some cod science principle called reverse entropy. Anyway, it left us in need of going to see it again. So I was writing to a student the next day to arrange a meeting. And I said, by the way, we went to see Tenet last night. Our brains are still bent out of shape, but we planned to see it again last week, so we'll understand it eventually. This is what passes for humor between me and my students. So clearly, I meant to say last week, but Gmail has this fascinating feature called Smart Compose. If you let it, it'll write your emails for you. So you tab through suggestions from the Google language model, and it will do all of the niceties and the polite parts of your email, and you just fill it with the meat. So it's like building a sandwich. It gives you the bread and you put the filling in yourself. And if it thinks you've made a mistake, it will underline your mistake. So it underlined the word last in blue. It's very helpful. It often spots my mistakes and I correct them. And I really like this feature of Google Gmail. But clearly it missed the joke here. And I don't blame it. I mean, it's what language model is going to know enough about the movie Tenet and time travel and reverse entropy to know that I was making a joke. Now, my joke is irony. And irony is different than sarcasm. They're siblings, but they're different. With irony, you can mean what you say and still be ironic. So there's a point at which I meant last week, in this fantasy world in which I'm a time-traveling super spy, I can go back in time and watch the film again last week. But in reality, I'll have to watch it again next week. So I meant last and next. There's no mistake here. But poor Gmail, it doesn't have a sense of irony, doesn't have a sense of humor. It simply says, I think this is funny, peculiar. It doesn't recognize funny, haha. So we can get statistics to recognize funny, peculiar, but not funny, haha. We need something else to fill the gap. So we can get halfway there with statistics, but not all of the way there. And just to give you another example, I used to have a different joke for this slide, but I got into trouble for it. The funniest jokes can strike audience members in unexpected ways. So I replaced it with a pun. I've never been married, but I've had a few near misses. And this is another example of an optimal innovation. Language models quantify syntagmatic expectations, but they don't really give you the conceptual model behind those expectations. Here's an example from The Tonight Show with Jimmy Fallon, which is not a pun, but shows the same mechanism. A company in Seattle just came out with a new bacon flavored cola. So if you love the taste of bacon and you love the taste of cola, you're about to realize how much you love them. Blah. And the expectation is he's going to say it together, because that's how adverts work. But the final line in Jimmy's joke is separately. If you love the taste of bacon and you love the taste of cola, you're about to realize how much you love them separately, because this combination sounds disgusting. And a lot of the jokes that you see on late night TV are about these weird innovations. And in the book, I write about how theories of innovation like TRIZ or TIPS, the theory of inventive problem solving, can explain jokes, or theories of jokes can explain inventive problem solving. They're very, very closely related phenomena. For again, the language model can say that you're expecting together, you get separately. These aren't puns, but separately and together are opposites. So there's a semantic connection here rather than a phonetic connection. So we can have phonetic connections, semantic connections, conceptual connections, pragmatic connections. And depending on the kind of connection between what you see and what you expect, you're dealing with irony, sarcasm, punning, or whatever. But the key here is that we need two language models, or certainly we need two models. They may not both be language models to understand and produce humor, because we need a kind of parallax or double vision. To return to the catastrophe theoretic approach, the producer, the joke teller or the joke writer, can see both models at once and can sample both models at once. So they can see that the consumer's model is going to expect a certain outcome, and then they can produce an outcome that defies that expectation. And it requires then that the consumer adapts their expectation accordingly. So the teller has a double vision, and you hope that the consumer has single vision because they're operating within a single model. And the result of the joke is that the consumer updates their model and they have a broadened perspective on the world. But we definitely need two models. As you can see with the Gmail example, one model to recognize the funny peculiar isn't enough. We need a second model to actually come true and to recognize the difference between a mistake, as in beer and wives, and a deliberate joke, as in see it again last week. Without two models, you could never tell mistakes from deliberate jokes. The second model could be a knowledge graph-based model, a symbolic model. The primary model is probably a statistical language model, and this is a prime area in which you get this symbiosis between symbolic and statistical approaches. You absolutely need it for humor and for creative phenomena generally. I mentioned earlier that there is this distinctive temporal signature for jokes that occurs again and again at different levels in the joke. So there's the temporal signature of the check joke that Mike the supercomputer generated, where you make the value of the check bigger and bigger and bigger. You make the number on the check bigger and bigger and bigger, and the value of the check goes up and up and up. But there's a point at which the number is too big and the check's value collapses. And then there's the mood of the listener or the recipient. So as you're looking at this check, your excitement levels build and build and build, and then you realize you've been punked and your mood collapses. And this is reflected at the brain activity level too. If you look at event-related potentials, or ERPs, for for jokes, we see that about 400 milliseconds after the onset of the anomalous stimulus, there's a peak in brain activity. And this N400 peak is associated with semantic processing. And we see it peaking when people are presented with jokes and metaphors and other challenging phenomena. And the peak reflects the amount of effort that we have to do to reconcile what we're given with what we expected. So you see this temporal signature everywhere in jokes, and you have to model it. And the peak is created or can be modeled, or the upswing can be modeled with one model, but then the downswing and the interpretation of what it means needs to be interpreted with another model. Let me give you an example. I'm going to give you a non-humorous stimulus, and I'm going to ask you to make one change to make it funny. A pair of suspicious fellows walks into a bar. The barman looks at them and says, "I'll serve you, but just don't start anything." Now, let me put this in context. I started with a joke from the Edinburgh Fringe. I was raised as an only child, which really annoyed my sister. Now, if I was to ask you, please generate a joke that uses both senses of the word as equals is and as equals like, it's really hard to do. If I asked Jerry Seinfeld to do that, not that I know him, but if I asked him to do that, he couldn't do that. But if you heard someone say, "I was raised as an only child," you might think to yourself, why is this person saying "I was raised as an only child"? Why aren't they saying "I am an only child"? Is there something happening here? And then you might interrogate the word as, recognize it's ambivalent, it's ambiguous, and then do a what if scenario. So a lot of jokes arise because we see something and we consider the what if alternative. So what is the what if here? What suspicious fellows would walk into a bar to make this funny? Anyone got a suggestion?
Feel free to
Yes.
jump in.
Hmm?
Oh, no, I was encouraging people to jump in if you have any suggestions.
By the way, this joke is from Reddit, so don't expect a thigh slapper, I'm afraid. Anyway, the joke is a pair of jumper cables walks into a bar. The barman looks at them and says, "I'll serve you, but just don't start anything." Now, I went through thousands of jokes on Reddit to find this. So many of the jokes are sexist or racist or not funny. It's really difficult. And I ended up getting a pun. Now you might think all he's talking about are puns. No, it's just that puns are the easiest ones to get across in a way that won't offend anybody. Anyway, so what's going on here? Start anything, as in start a fight, versus start a car. You see how that fits the Victor Raskin two-script model? Now, how would this allow us to generate jokes? Well, you take an innocent stimulus, and then you try to find a point of divergence and replacement. And the replacement has to somehow fit multiple constraints at once. Notice how we imagine jumper cables walking into a bar, which is a very silly thing, but somehow we're able to do it. We suspend disbelief. And it all allows us to then have a double meaning for the word start down here. So the idea of jumper cables walking into a bar isn't the funny part. It's the double meaning of the word start. I know it's a bit of a letdown, but that's the way these things work. Now, you might think, what if we fed all of these jokes from Reddit into a language model, a really good language model? You could take GPT-3, for instance, from OpenAI. If you have a small enough set of jokes, maybe you could just use GPT-2. And I was reading this article by Peter Baumgartner where he did exactly that. He took the GPT model, he took the small parameter model, 124 million parameters, and he took the 20,000 Reddit jokes, and he fed them into the language model. The idea being that if there's something in the language of the jokes, the model would pick up on this and generalize. Here's another clean example from the data set. My father has the heart of a lion and a band from the local zoo, right? So here, heart is interpreted in two different ways, metaphorically and physically. Right, so what kind of expectations do you have of success here? I imagine that none of you are expecting this experiment to turn out well, and you'd be right. So after 250 epochs of fine-tuning, this is the kind of thing the model generates. What did a priest say after an elephant died? What is it for? What, after 750 epochs? Why did the chicken cross the road? To get a job at the hen. What do you call a man with dyslexia? A dyslexic. That's actually passably funny. It falls into a form of humor we call meta humor, where the joke itself isn't funny. It's the expectation of a joke being funny that's dashed that produces some kind of humor. It's the chicken crossing the road to get to the other side is an example of meta humor. After 1,000 epochs, puns aren't jokes, they're punchlines. Okay, after 1250, how much is 50 cents for an idiot? The mathematician says, not that much. I just went bowling. There's a kind of a Monty Python quality to that, but it's still not funny. After 150 or 1500 epochs, the model generates, why did the chicken cross the road? Because it had no legs. This actually reminds me of IBM's Watson. It answered a question on Jeopardy. The question was, what was special about this gold-winning Olympian, I think from a certain Olympics, who won he won the gold for the parallel bars. And the human said he was missing an arm. As much as you might try, you cannot do the parallel bars with one arm. And Watson said he had a leg. Now the answer was he had one leg. This person who won the gold for parallel bars had one leg. So he had one leg missing and one leg present. So Watson was technically correct. He had a leg. And the human was wildly wrong. But Watson didn't know why it was right. He didn't imagine what it was like to do the parallel bars, missing an arm, missing a leg, and so forth. And here, why did the chicken cross the road? Because it had no legs. Very silly answer. If it said, why did the chicken cross the road? Because it had legs, that might be better. So the point is that a single model isn't good enough to generate jokes. Even if you give it the best jokes in the world, it cannot generalize from them without knowing what the unfunny variant is. You need two models and you need this tension between them. And I think one of the models needs to be a statistical model. One of the other models, I think, would best be a symbolic model. So a single model cannot surprise itself, just as we cannot tickle ourselves. You need two models and you need to cultivate a tension between the models. And the models generally align with the producer's view of the joke and the consumer's view of the joke. And it mightn't be a joke. It could be an advertising slogan, a song lyric, a metaphor, a maxim, an aphorism, a headline, something that plays with expectations. So we've been looking at symbolic models. I don't really have time to go into them. Our robots died during COVID. I wasn't in the office and their batteries have died, but we use two now robots to act out stories that the machine generates using an entirely symbolic model. And we use Alexa to narrate the stories, and the robots move around on stage and they articulate and they're actors playing the roles of characters in the stories that the machine generates. Here's an example of Jane Marple falling in love with Reginald Jeeves. And we can put play acting and irony and punning and all sorts of things into the performance. And that's generally where we are with humor. We explore it symbolically, but we're interested in capturing the expectations that the symbolic model must violate using statistical analyses of large corpora. Okay, I'll leave it there and I'll take your questions if you have any.
Awesome. Thank you so much, Tony. I do see maybe Derek, it looks like you had a question. Do you want to come off mute and share that?
Yeah, I was just curious how you think about the nature of how funny something is versus whether it's a joke or not a joke, and what's your approach to that question?
Right, actually that's a very good question. There are multiple levels at which you can recognize and quantify humor. So yes, is something a joke? In humor theory, there's a whole scholarly area to do with humor. It's actually a very old area that goes back to Aristotle. We talk about humor potential. So some jokes are unintentional, of course. So we talk about whether a stimulus has the potential to be interpreted as a joke. So some things that we laugh at can be very funny, but they were never intentioned as a joke. So we talk about, is something intentioned as a joke? Does something has the potential to be a joke or interpreted as a joke? And in a certain context with a certain audience, does it actually work as a joke? Right, so computational models often focus on humor recognition, which is akin to modeling intention. So is this tweet intended as a joke? When someone says, if JFK had been vaccinated, he would still be alive today, get vaccinated. Are they using the hashtag get vaccinated sincerely, or are they using it ironically? Is this tweet intended as a joke or not? So that's a binary distinction. Now, whether it works better as a joke than something else that's intended as a joke, that's really a question of subtle quantification. And we can build computational models of that too. For instance, Bob Mankoff, who was a long-time cartoon editor of The New Yorker and who is a humor scholar, he has a PhD in psychology of humor, did some work with machine learning researchers from Microsoft on a data collection that he had collected over many years from the New Yorker magazine. They had a weekly caption contest where they would present a New Yorker cartoon without the caption, and they would invite readers to provide their own captions. And then they would pick, human judges would pick the best of the readers' suggestions. But using that data and the judges' selections over many years, they were able to train a machine learning model to try to rank different captions for the same cartoon. And the model was evaluated on how well its rankings chimed with the human judges. So that was really all about modeling the extent or the degree to which something is funny. If we accept that everything that's entered into that contest is intended to be funny and then rank them by actual perceived funniness, that's a harder task. And they came up with some really interesting results. Their machine learning model, for instance, ignored the cartoon itself and just worked on the caption. And it got some good results. There's something inherently comical about the structure of language used in cartoon captions that a machine can recognize independent of an understanding of the visual image itself. They tend to work with cliches, familiarity. They used measures such as perplexity, and they got quite a bit of the way. They added some meta information as well about the contents of the cartoon, and that pushed them a bit further. But they were able to say, given these two possibilities as candidates for captions, which will work better with the audience? And their model was able to quantify that. I think that's what you're talking about here, right? Is to what extent is one thing funnier than another? Can you quantify that? And the answer is, if you operationalize it in the right way, you can quantify that in the context of a specific task.
Thank you.
You. And I see another question from Steve Hersker, who, but I think you actually talk a lot about this in your book, if I remember right, about the context. But Steve, maybe you want to share your question directly?
Yeah, so it was interesting to learn that there's two models, one for the producer and one for the consumer. But some people find any given joke funny and others do not. So my example in what I typed in was that some people love puns and some people hate them. So it almost seems like the consumer models have to be very personalized, if you will, to make a joke that strikes a particular person funny. So how does you account for all that?
Yeah, so, and I mean, human comedians do this too, of course. The audiences for human comedians tend to be self-selecting. So there are some comedians on this side of the Atlantic who specialize entirely in puns. And you hear a few of their jokes and you think they're funny, but my goodness, I couldn't sit through an hour of that. And then there are people who prefer the more narrative experience where someone speaks for an hour and everything is coherently connected as part of an overarching narrative. And none of the particular points in the narrative are jokes, but the whole experience is funny. And that appeals to a different audience. And yes, you need to know your audience. So for instance, the jokes in A Christmas Cracker are aimed at children, and the adults who have to read these things out, they always groan, right? And I claim I hate puns, but I make a lot of them. The book is full of them, actually. I'm a bit of a hypocrite about puns. But yes, you address the type of humor to your audience, and that's a classic user modeling, isn't it? If you're doing this on Twitter, for instance, you can understand a user's behavior by how often they like or retweet certain of the stimuli that you're working with. And if you're breaking the audience into segments, then you can use that kind of statistics to drive a model. And if your model is capable of generating multiple types of jokes and the audience expresses a preference for one or the other through feedback like that on Twitter, then the model can adapt accordingly. You probably have different models for generating jokes and for generating narrative jokes, for generating puns and for generating witticisms and more conceptual types of humor, and adapt accordingly. Heather Knight at Oregon, she uses audience feedback. They hold up colored paddles, which her now robot can see. You put up a red to say I didn't like that, or a green to say I did. And that gives the robot some understanding of what the audience likes. And then the robot will choose its material to suit the preferences of the audience. With irony, we tend to use irony to divide audiences into those who get it and those who don't. Irony is a particular kind of humor where we take satisfaction from knowing that some of our audience simply won't get it. And that increases the humor of the people who do get it. So there are lots of strategies in humor for addressing that user modeling issue. Sometimes some strategies try to make everyone part of the act, and some actually try to exclude some people. And it depends on what your goals are. If you're building a robot sense of humor for a home care assistant, you probably don't want to dial up the sarcasm, right? And you want the robot to adapt to the user sense of humor. So if the user hates puns, you certainly don't want your home care robot to be trolling them with puns all the time. So yes, feedback is going to be very important. And machine learning was, of course, that's a natural thing for machine learning systems to do.
Yeah, great. Thank you.
We have 4 minutes left. Maybe there's time for one more quick one, and then we can call it.
I had a question.
Yep.
So it seems to me you really need a good knowledge graph to navigate based on some reasoning rules in order to, account for the symbolic part. I wanted to ask if you know of any knowledge graph that has already been built that it's good for this. Like, what do you use for your models to do this type of navigation?
Okay, our symbolic systems work within this storytelling system that we've built called Scalextric. Scale is the Irish word for story, so there's another terrible pun for you. And of course, Scalextric is a famous brand of slot car racing system where you click the tracks together and you have these little electric cars zooming along them. So we have a storytelling system that's got these thousands of prefabricated plot segments that the system pieces together into arbitrary tracks, and then the characters are moving along these tracks. So it's kind of a closed world that has relevance to the listener because it uses famous people in its stories. It's got a big database of famous people and their attributes. So for instance, it knows about Donald Trump, it knows about Darth Vader, it knows about Vladimir Putin, and Count Dracula, and so on. And it will try to mix and match characters in kind of ironic ways. For instance, it might mix Alan Turing and Doctor Strange. It's kind of because it's playfully playing off the fact that it knows that Benedict Cumberbatch played both of them in movies and so forth. So it's trying to add layers of interpretation to what it's doing, but it's all symbolic. Trying to get augmentations to the symbolic structures using machine learning techniques is possible, but there's a terrible fear that something will slip in there that will be offensive to the audience. And we've had occasions where our robots say unconscionable things to people. It learns similes, for instance, from the web, and sometimes it will say something that will shock the audience. Actually, these robots are always getting us into trouble because they say things that are quite innocent. For instance, in one of the stories, the machine reinvents the story of Luke and Leia from Star Wars, and Luke and Leia fall madly in love. And then the robot playing Leia says, "I'm going to cook you an exquisite meal." And one of the members of the audience said, "That's so sexist. Why is Leia doing the cooking?" We didn't know how to answer that. Do we stop female characters from cooking in the stories? Do we take cooking as a verb and as an action out of the knowledge graph? What do we do? And our solution is to try and have the system detect the perception of bias and then to preemptively joke about it itself. And that's another reason why you might give an AI system a sense of humor, is to preemptively identify sensitive areas and to tell people, I'm aware of this, people, don't take it too seriously. In another case, we had the robots performing a story about Donald Trump and Hillary Clinton, and they fall in love. The stories involve a lot of love triangles and dark endings, very dark. And so Donald proposes to Hillary, and then according to the Scalextric story system, Hillary says yes. But the performative aspect of the system needed a reason for Hillary to say yes. The narrator is Alexa. So Alexa is going to say, Hillary said yes because. So the system went looking for a reason why someone called Hillary would say yes to a marriage proposal from someone called Donald. And it looked up its model of Donald in the database. And it said, I'm going to pick 2 positive properties of this Donald to put into the explanation. So Alexa said, Hillary said yes to Donald because Donald was rich and powerful. Okay, so that was the machine's performance of a machine-generated story. And we submitted a paper to one of the ACM conferences. And the reviewer said, this is so sexist. We like some of the work, but you're going to have to change the video before we can allow this to be accepted. And they assigned a shepherd to us to make sure that we changed the video. They said that we were enforcing the gold digger trope. Now the machine was completely innocent. Maybe we were less innocent. Maybe we should have spotted this. Anyway, the point is that even accepted knowledge and simple algorithms with no bias can produce outputs that people think are insensitive and can be quite offended by. And that's within the controlled world of a knowledge graph that we have built ourselves over many years. If you use machine learning to update this knowledge graph automatically, then the potential for offense is magnified greatly. And that's one of the areas that we're working in. There's a chicken and egg situation here. Humor is transgressive, so you need to know where the line is before you can find something funny. But we also know where the line is because we have a sense of humor. So one feeds off the other. So there's great potential here for offense detection research, which, as you know, lags far, far behind our generative capabilities. GPT models are wonderful at generation, but the statistical models that detect whether what's output is offensive or not are woefully inadequate. And humor research really points that up, that we're really lagging behind in our ability to detect when something that is machine generated has the potential to be offensive. That's the flip side of humor research, and perhaps the most commercial and driving reason to look into this area of AI research.
Awesome. Thank you so much. On that note, a really deep thought to end on, but really appreciate your time. Thank you so much, Tony, and everyone for joining.
Thank you, guys. Email me
Following
for
up.
more details or materials or just to shoot the breeze about this.
Absolutely. We'll be following up. All right. Take care, everyone. Bye.
Thanks,
More
guys.
details in the book.
Yes.
Bye-bye.
Also true. Take care.
Take care, everyone. Thanks.
Bye-bye.
Hi, thanks, Tony.